All right, hello, welcome to the video. This is a video on water quality and kind of restoring freshwater ecosystems. We're going to measure a lot of water quality parameters, and I thought making a video would be useful to kind of go over how we go about measuring these things. They're all quantitative, so we're going to get a number for each of them. I've talked a little bit about dissolved oxygen already. We need dissolved oxygen in the water for the animals and the bacteria to live in order to decompose the dead stuff and kind of keep the organism or the ecosystem running. The colder the water is, the more dissolved oxygen has. Also, the faster moving, because the faster it goes, the more riffles you get. So if you're talking about a stream that's really dashing over some rocks and stuff, it's going to have more dissolved oxygen, which will allow different species of animals to live in it and change the decomposition rates and all that good stuff. We can enter it in a couple ways. One is through the surface, which is just where you get oxygen molecules bouncing off the surface of the water. Some of them will pass through and dissolve straight into it. We can do aeration, which would be like the bubbler pumps you see inside aquariums, or like the fountain you see out in the pond on our campus here. That fountain is there to oxygenate the water and keep the decomposers alive. Aquatic plants also make water, and so if you've got plants growing underwater, like in our eco columns, the duckweed growing in there is going to help dissolve more oxygen in it. How do we measure it, or why do we measure it? We measure it because it's there to support life, and so you know, the ideal range here is between 7.4 and 9 ppms, and so we measure it using these SNAP tests, and we've used them before, but just to refresh your memory, you would take a sample of water in one of the little SNAP beakers and use the fresh SNAP test in it, snap the tip, it'll suck it up automatically, and then you compare it and see what it falls for. And so the range we're looking for is anywhere from here all the way over to here. And so that is ideal. If you're down in this range, everything's going to be dying. If you're in the range in between here, this would be stress. It's not comfortable for them to live in that range. pH is another good test to do. Remember, we're looking for that 6 to 9. 7 is neutral, but 6 to 9 on the pH scale is going to give us a healthy ecosystem. The lower it is, the more acidic it is, and so typically, if you have a lot of decaying, dying stuff, you're going to have acidity increasing a little bit. And just to remember that every number on the pH scale, so if we're talking about a 6 to a 7 difference in pH, the 6 here is 10 times more acidic than the 7 would be. Each number is a scale of 10. And so it's important to remember that 6 to 9 doesn't seem like a very large scale here, but each number there is 10 times less acidic than the previous. Why do we measure it? It's an important factor here. Just kind of biologically, the proteins and stuff can denature if the pH is wrong. And so if it's less than a 5, nothing's going to survive. Here's your ideal. We can use one of these guys to measure it. I have a digital pH scale, and so it's as simple as uncapping it and sticking that end in the water sample and taking a reading off of it. Litmus paper would work too. Turbidity. This is something we see very clearly in our river out there. It's very dark in color. This is a measure of how clear the water is, and so we would have very turbid water in the St. Johns River. It's a measure of suspended particles in the water, so things that are dissolved and floating in the water can block light from passing through it. The more of those particles you have, the less light that can pass through it. This is very important because if you have high turbidity, right, if turbidity is very high, then the amount of plants are going to be very low. Remember, we talked about the photic zone in the last slide. If you have a body of water with low turbidity, that photic zone is going to be much lower and allow more plants to grow. If you have high turbidity, and we're talking the same body of water here, that photic zone is going to shrink, and that's making the amount of space to grow plants much smaller. How do we measure it? This is called a Secchi disc over here, and simply what you do is lower it down into the water until you can no longer see the difference in these edges here. And so once you can no longer see the difference between the black and the white, we get a measurement. The measurements are in JTUs, or Jackson Turbidity Units. Temperature is really important. Temperature, because it affects DO, is very important to know, but also temperature itself can also denature proteins in living things like plants and animals, and so too hot, too cold is not very good. High temperature, you're going to have more decomposition happening, and that can reduce dissolved oxygen. In addition to, high temperatures mean the oxygen molecules in the water, along with all the molecules in the water, are moving faster. They've got more average kinetic energy, and so it's easier for them to break through the surface and escape from that body of water. Measured with a thermometer. Nitrates are another good thing to check. A lot of these nitrates come as runoff in some fashion. They can be runoff from septic tanks leaking into the water supply. They could be runoff from fertilizers that we've sprayed on croplands within the watershed, and so they're very good for plant growth. The problem is if we have too many of them, it's a bad thing, and you've heard of the term eutrophication, but that is what happens with too many nitrates, because nitrates are often a limiting factor in aquatic plant growth. There's not a lot of natural nitrogen there. So if we supply a lot of nitrogen, plants are going to explode in population, and as they die off, you end up with more decomposers, and so it kind of knocks it down. We measure it the same way as DO with a snap test. The procedure is a little bit different, but it's essentially the same test. What we're looking here for nitrates is between 0.1 and 0.3 ppms. It's enough for plants to grow, but not so much that they can overtake everything. This is a good indication of pollution if we find high nitrates in the water. Phosphates, very similar to nitrates. These are a huge limiting factor for aquatic plants as well, and so if you get a lot of phosphates, you're also going to see eutrophication. Algae would be part of that plant life that would explode in growth if you introduce a lot of phosphates. Fertilizers, detergents in this case, like your laundry detergent, industrial detergents used for processing paper, that kind of stuff, are going to cause phosphate pollution. Again, we're going to measure it via a snap test. Procedure is a little bit different, but it's essentially the same test. The ideal amount of phosphates is very low. We don't need a lot of phosphates for plants, and so we don't want to introduce too many of them. A couple things we can do. So if we have a stream that is degraded for some factor, there's some things we can do to restore it and kind of bring it back to a healthy ecosystem. One of the things we can do is to decrease the slope of the banks. A steeper sloped bank is going to give you a narrower and deeper body of water, a stream, which means it's going to go faster. It's going to run much quicker. It also limits the space you have for plants to grow along. So by decreasing the slope, you get more room for plants to grow. Those plants are going to help hold sediments in place. They're going to catch fertilizers and runoff as it tries to get into the stream and hopefully use up some of those nitrates. The stream will run slower, and so there's less erosion within the stream. And so it would reduce a lot of stress on this ecosystem just by decreasing the banks. Another thing we can do is by reforesting the riparian zone. And so the areas around, kind of like I explained earlier, the more plants you have, the more of a buffer zone you've got there. It's going to reduce the erosion because the roots are going to hold on to the soil, and so you're not going to get erosion running down into the stream and causing sediments to build up further and further and further down. You can also reduce that erosion by putting in cinder blocks. Here, if you're going along the river, you probably see a lot of people's yards that back up against the water. They've put some sort of structure there, a bulkhead, cement, wood, metal, something there, stones. You see big blocks of cinder blocks out there that will prevent their yard from eroding away and into the river. And so you can also use vegetation to do that. That's kind of the more natural way, but both of those are effective to do it. Another way you can kind of increase the health is create riffles and pools. And so the riffles are going to help because they add more dissolved oxygen to the water, which means more life and more decomposition can happen, which is always a good thing. You're getting more nutrient cycling happening that way. It also is going to slow down the stream. That water that previously could run straight through the stream, if we construct a big rock or a log on the way, that water now has to go up and go up and so it's decreasing the speed of the water. By creating a pool, you're doing the same thing by slowing the velocity of the water. Again, if you picture that water running over a surface, if you deepen that body, now the water enters and it's got to go down, and it's going to fill this up a little bit before moving on. And so it's decreasing the speed, which reduces erosion. One way you can do it is a cut and fill, and so if we widen the channel, it's going to be similar to how we reduce the steepness. If this is our previous channel, that water is very narrow and deep, and it'll just run fast, which can increase the erosion. If we keep the same steepness, but we widen it out, now that water has a much larger area to cover, and so it's going to move slower down the stream. Adding a waterfall. If we build an artificial waterfall, this is going to give a huge boost to the dissolved oxygen. All that white water you see in the waterfall is exposed to air, and so it'll dissolve oxygen and allow aquatic life to build up. Waterfalls are also going to kind of naturally trap a lot of garbage or floating debris in the streams and prevent it from moving on downstream. And so that's all we've got for you on the chemical parameters we're going to test in class and hopefully on the field trip, along with how to restore a stream to its natural beauty. Thanks for watching. Please bring some notes and be prepared to discuss in class tomorrow.